So now let us move into carbocation intermediates. Carbocation intermediates. So carbocation means the carbon will be carrying a positive charge. Okay. Carbocation intermediate. So it will be a group of atoms having a positively charged carbon containing only 6 electrons. 6 electrons in its valence shell. So it will be lacking in electrons. So it is carrying a positive charge. Now how it is formed? By hydrolytic cleavage. Hydrolytic cleavage. So if the atom which is attached to carbon is more electronegative than carbon, so during hydrolytic cleavage, it will take away both the electrons with it, leaving a positive charge on the carbon atom. And it will carry a negative charge. Okay. Again, the alkyl carbocations are of 4 types. So one is methyl, primary. So it is also written as this. Now do not call it 1 degree. Some students start calling it 1 degree. It is not 1 degree, it is primary. Okay. Then third one is secondary, written as this. Fourth is tertiary, written like this. Okay. Now we will be understanding how to explain the stability of the various types of alkyl carbocations. Okay. So if we see the structure, this is the methyl carbocation. This is the primary. In case of primary carbocation, the carbon which is positively charged will be having 1 carbon attached to it. If the carbon having the positive charge is further attached to 1 carbon, it is a primary carbocation. So now here we have 1 carbon attached to the positive carbon. If we are talking about the secondary one, then it will be having 2 carbons attached to the carbon containing the positive charge. Then 3 carbons attached to the carbon containing positive charge. It will be forming the tertiary carbocation. Good. Okay. Now next we are moving into the stability. So the order of stability, you will be telling me in the comments below. I'm explaining it to you how to know the order of chemistry, how to explain the order of stability, right? Now, there are 2 methods, 2 ways using which we can explain the stability of the carbocation intermediates. So number 1 is by using plus I effect. Now, if we consider CH3 free radical, it is not having any alkyl group attached to it, so there will be no plus I effect. And there will be no delocalization of, not delocalization, you can call it dispersal. There will be no dispersal of the positive charge because there is no group having the plus I effect. Now I will be showing it to you in the next types of carbocations. How is it explained? Now we have already studied that methyl group or the alkyl groups, they have plus I effect. Now, what is the burden on this carbon? This carbon is containing a positive charge. So this is a burden on the carbon. So anything which will relieve this carbon of this burden, it will be stabilizing this carbocation. So because CH3 is having plus I effect and it will be releasing its electrons towards this positive carbon. So it will be dispersing the positive charge. So greater the dispersal of the positive charge, greater is the stability. So in case of primary carbocation, there is only one alkyl group which is dispersing the positive charge of this carbocation intermediate. Now, if we consider the secondary carbocation, there are two methyl groups which can disperse the positive charge of this carbocation, the positive carbon. And in the third case, the tertiary carbocation, here the positive charge is dispersed by three alkyl groups. This means there will be more relief to the positive carbon. So it will be the most stable. So just you need to tell what will be the order of stability of the primary, secondary, tertiary carbocation intermediates. Fair enough? I think you should be able to do that. Then next is, we are moving to benzyl carbocation. Just like we did the benzyl free radical, now we are moving into benzyl carbocation. Benzyl carbocation. So this is the benzyl carbocation. I think I have forgotten to explain the second way of explaining the stability of the various carbocation intermediates. Let us do it first. So we will be coming back to the benzyl carbocation. The second way of explaining the stability of the alkyl carbocations is hyperconjugation. Hyperconjugation. Greater the number of hyperconjugating structures, greater will be the stability. So in case of methyl carbocation, there is no alpha carbon and hence no alpha hydrogen. So no hyperconjugation will be possible. In case of primary carbocation, there are 3 alpha hydrogens. So 3 hyperconjugating structures are possible. So I will be drawing only for the primary carbocation intermediate. The rest you will be drawing yourself. Okay. Do not skip drawing it. I tell you, this is going to help you. The writing practice is going to help you a lot to improve your results. So here, this H will be having a positive charge. Here will be double bond CH2. So this is the way how we draw the hyperconjugating structures for the primary carbocation intermediate. So 3 alpha hydrogens are there, 3 hyperconjugative structures are possible. So in case of secondary carbocation, there will be 6 alpha hydrogens and 6 hyperconjugative structures will be possible. Then in case of tertiary, there will be 9 alpha hydrogens and 9 hyperconjugative structures will be possible. Good enough? So I think now you have got the practice. A lot of practice you must have done. If you have not done the practice, do it now and apply the concepts on this and explain it. How you can explain the stability of free radical and carbocation intermediate on the basis of hyperconjugative structures. Now we are moving into benzyl carbocation. Benzyl carbocation. So in this case, we will be explaining the stability of this carbocation on the basis of resonance. So now here the pi electrons are involved into conjugation with the positive charge. So there is one bond distance between the positive charge and the pi bond of the ring. So it can move to this side. Now, one thing very important, always we need to show the movement of the electrons. A positive charge means that the space is empty and the empty space does not move. Okay. So if there is a positive charge, this means the electron is not available. If the electron is not available, how will it move? So you cannot show it that positive charge is moving. It cannot move. You will be showing only the movement of the electrons. Okay. So make it very clear that movement of electrons needs to be shown. So I'm drawing it here now. So it will move here. Now, here will be the double bond. This carbon will carry positive charge. Okay. Okay. Now, next, this positive charge is there. This bond will move here. Here is the positive charge. Now again, this is in conjugation with this bond. Here is the positive charge. Now it is in conjugation with this double bond. The positive charge will come back to CH2. So this is how we explain the stability of the benzyl carbocation. Okay. Now I give you an assignment for this. If we have 3 benzene rings, C6H5 means benzene ring. If you count the number of carbons and hydrogens in this very benzene ring, you will be finding that there are 6 carbons and 5 hydrogens. So if there are 3 benzene rings attached to the carbon containing the positive charge, and then if there are 2 benzene rings attached to the carbon containing the positive charge, and one we have already done when there is only 1 benzene ring attached to the carbon containing the positive charge. Now you need to tell the order of stability of these 3. Okay. Now greater the number of resonating structures possible, greater will be the stability. Throwing a hint. Okay. Greater the number of resonating structures possible, greater is the stability. Right. So just do it. Okay. Next we are moving to allyl carbocation. Allyl carbocation. It is CH2 double bond CH, single bond CH2. Here is the positive charge. Now this positive charge and this double bond, they are in conjugation with each other. So this bond can move here and it will lead to the formation of the carbocation on the other carbon atom. So this is the case, right? So allyl carbocation is also stabilized because of resonance. So now let us move into the structure of carbocation. Structure of carbocation intermediate. Okay, when we are discussing the alkyl carbocations, here we have a positive carbon to which there can be 3 hydrogens attached. There can be 1 alkyl group, 2 hydrogens, 2 alkyl groups, 1 hydrogen, or all 3 alkyl groups can be there which are attached to the carbon containing the having this positive charge. Now this carbon atom which is having the positive charge, it is sp2 hybridized, forming 3 sigma bonds with hydrogens, with hydrogen atoms or alkyl groups. So again, just like free radical, it will also have the planar structure. Planar structure will be there. So we can draw it like this. The one unhybridized p orbital is empty. So this p orbital is empty. Okay, so in the next video, I will be discussing the carbanion intermediate. Now, one more thing I want to tell you here, the carbocation was also known as, previously it was also known as carbonium ion. Carbonium ion. Now the carbocation term is used. So you should know what is a carbonium ion. It is a carbocation only. So let us move to the next video and discuss what are the carbanion intermediates.